Welcome to this quick explainer designed to get you exam ready on the topic of embedded systems. This is a really important part of the OCR J277 specification, so we're going to cover everything you need to know to nail those questions.
All right, let's start with a question to get you thinking. What on earth do a microwave, a digital watch, and a car's engine all have in common? I mean, they seem totally different, right? But believe it or not, they share a crucial piece of computer science.
And the answer is they're all controlled by a special type of computer system known as an embedded system. They're basically the hidden computers that power so much of our daily lives. Okay, let's dive into what that actually means.
Right, for your exam, the very first thing you absolutely need to know is the definition. Seriously, get this locked down and you've got the foundation for any question that comes your way.
So what does that really mean? Well, think of it as a computer that's been embedded or built inside another device. Its entire job, its whole reason for being, is to do one specific thing and do it really, really well. It's a total specialist, not a general-purpose machine.
Now, let's move on and see how this all builds. To really get what makes these systems unique, we need to look at their key characteristics. The exam board loves asking you to compare them to general-purpose computers like your laptop, so this is super important.
Okay, this comparison right here is absolutely golden. The best way to remember this stuff is to think about how an embedded system is different from your laptop. An embedded system is laser-focused on one job, right? Your PC, though, it's a jack of all trades. It can browse the web, play games, do your homework, the works. And because embedded systems are so specialized, they can be incredibly efficient. They use very little power and memory, which makes them cheap to make and super reliable. And the user interface? It's usually super simple, maybe just a few buttons and a tiny screen, or sometimes no interface at all.
So the crucial point is being able to apply all this knowledge. It's one thing to know the theory, but the specification requires you to be familiar with a whole range of real-world examples.
Think about a modern washing machine. Its brain is an embedded system that's dedicated only to washing clothes. It takes your input, the cycle you choose, and then it perfectly controls the temperature, how fast it spins, and for how long. It's not trying to check your email, it's just doing the laundry.
A digital watch is another perfect, simple example of a device built around a single-purpose computer. It's a complete system right there on your wrist, but it's totally embedded, and its whole world revolves around keeping time, setting alarms, and maybe a stopwatch. That's it.
Now for a more complex example. This one shows how these systems can perform absolutely critical, real-time tasks. In a car, the engine management unit is constantly making split-second decisions about fuel and spark plugs to keep the engine running at its absolute best.
And this one brilliantly illustrates that dedicated function. A GPS doesn't browse the web, it just navigates. The entire system, the hardware, the software, is optimized for one thing: figuring out where you are and telling you how to get somewhere else.
Okay, let's bring this all together into a final checklist. This is what you must remember for your Paper 1 exam if a question on embedded systems comes up.
If you can do these three things, you have absolutely mastered the key knowledge for this part of the specification. First, you've got to be able to define it. Second, you need to describe its main characteristics, single purpose, efficient, simple interface. And third, you have to be able to give a few good examples. Do that and you're all set.
And to finish, here's something to think about. From your alarm clock this morning, to the traffic lights on your way to school, to the microwave you might use later, these hidden computers are literally everywhere. You've probably already used dozens today. They are the invisible engines of our world. Pretty cool, huh?